So I'm going to talk about off-air digital broadcasting, and I'm working in the technical area, so nothing political. I won't have any opinion on this. So mobile digital broadcasting. First, I'm from the Communications Research Center in Canada, so a government organization, 250 researchers. I'm one of 40 dealing specifically with digital broadcasting and audio and video coding and so on. So I think that when we talk about mobile convergence, we tend to forget that broadcasting is also part of the picture, the convergence to mobile and wireless infrastructure. So we have here a picture representing this, where mobile broadcasting or broadcasting, you have a big tower covering the whole city, and other options were wireless, 3G, internet through WiMAX, Wi-Fi, and so on. So different options, and broadcasting is there. So we're working in the transition. I've been working in digital broadcasting for 10 years now, and we're working on the transition going from analog to digital. But if you look at the technology itself, we could call it a technology for one-to-many telecommunications. And so what it is a specialized infrastructure that is efficient for the transmission of the head of the long tail, if you want. And we can reach very large, very, very large audiences with live content also, which is not always trivial with the other options that we have with the internet. For example, having HDTV over the internet is not easy. We start having live content over internet through peer-to-peer systems and so on, but having HD is not feasible right now, as we know, and could take some time before we reach that. So some of the options for mobile digital broadcastings. Here, we have different flavors, different protocols and standards for off-the-air transmission. A couple are driven by telecom operators, MediaFlow, DVB-H, mostly driven by Qualcomm and I forgot, Nokia, and the other ones coming more from the world of broadcasters. So World DAB is the DAB DMB standard. You have HD radio here in the States, DRM, and ATSC mobile TV, which is coming also here in the States. So I work specifically in digital radio. So looking at a transition from AM/FM to digital radio, we adopted in Canada the DAB technology some years ago, already 10 years ago. Broadcasters started deploying the technology, but right now, let's say it's more or less a status quo, waiting to see what will happen with HD radio here in the States. So, but the features of the DAB, it looks like this. It's a high speed. It should support high speed mobility, allowing the conversion from FM, which we all know we can receive in cars. The capacity per channel is approximately 1.5 megabits per second, so 16 gigabytes per day. So it should support high bitrate, high-quality radio, and high-quality video as well. So the video, typically for small screens, people are talking about 384 kilobits per second to 512 kilobits per second, roughly, which is quite a bit more than what telecommunication organizations are doing right now with a couple of frames per second. So DAB operates in 2 frequency bands using the COFDM modulation, and has the option of single frequency networks. I won't get into that because it can get a little bit complicated. So what have we done in my little team? We wanted to enable applications on top of this digital channel. So on the transmission side, a typical rack looks like this. You have normally in DAB, so you have several audio encoders per multiplex. So you have a device that's called a multiplexer in there, and you have a modulator also. So this is expensive, and this is closed also. It's not so open and to innovation. So what we've done, we sort of programmed most of the parts, so going from hardware to software. And this allows us to do something like this. So I have all a similar equipment here on my laptop right now. So that's very practical. Interesting savings also. So democratizing the technology so that people like you and other broadcasters and other people can play with the technology and innovate on top of it. One of the The thing that is not so easy, or is becoming easier, is to do the modulation in software. And thanks to projects like the GNU Radio project we saw yesterday with the OpenBTS project also, we have a box for $800 like this, with which we can do the DAB modulation. That's something we programmed at CRC. And so with very low-cost hardware, you can have a transmitter. So we were able to, if you look at all the pieces of software that we were able to build and that are required to have a full transmitter, there's a multiplexer, there are applications, there's this GNU Radio open source framework, GNU Linux, of course, a modulator, encoders for audio and video and other data applications. So this is great, and we thought if we want, again, to democratize the technology to our users, broadcasters, and technologists, we thought that we put all these software on a live CD. So all the pieces required to have the live transmitter are on this live CD. So you take the live CD, put it in a PC. You don't need to install anything. You plug the USRP, and you have a live transmitter running with one click. We call it the one-click transmitter. So that's more or less what you need. If you want to have some coverage, there's one piece missing here. This would be the high-power amplifier. So I looked and made a small simulation of what could be done using a 20-watt amplifier from mini circuits, $1,400 worth of equipment. If we put that on top of the hotel here, we'd have a simulated coverage that would look like this. Not very good because the hotel here is relatively low altitude, but still you see that we would be able to cover the airport, for example. And that's a simulation in the L-band, using DAB and L-band. So on the receiving side, so we've built a transmitter. I'm going to show that to you in a moment. On the receiving end, there's another issue. It's logical that broadcast services be received into mobile receivers. And but the problem here is that we have potentially colliding business models. And in fact, we observed that in Korea, where some typical broadcasting applications, one is called broadcast website, was not embedded in a commercial receiver because it's competing with services that mobile network operators offer. So the broadcasters want to have their free-to-air television model. That's the way they look at things, and MNOs come with the PTV model. So if we want to create applications for these devices, it's hard and actually not feasible. So 2 years ago, we started to look at options. Android was not that far, and the OpenMoko project was the most open platform there was, so that's what we did. We look, and if you look at the software stack back then, you would notice also that there was no plan by any of these projects to include broadcast chipset, and so there was no software stack for broadcasting applications and broadcasting, off-air physical broadcasting. So that's the part that we decided to do. So we made a software that we called OpenMoCast, Open Mobile for Open Mobile Broadcasting. So the software does receiver control, demultiplexing, application decoding, and the presentation of the application. And it can drive a small USB receiver. We took, so the other thing was to make a very nice and compelling prototype. So that's you see the level of openness this company has done. We were able to take the phone actually and generate from the CAD drawings our own piece. So make a small extrusion of the bottom of the device, and after a couple of days of work, we shipped that to a 3D printing shop, and it did cost $100 or so, and we got the piece like that after. So we were surprised that this was so easy to do things like that. So we managed to insert the USB key and connect it to internal, not necessarily USB port. We had to do some soldering there, but there were USB checkpoints on the motherboard. So that's how the prototype looks like. A little bit thicker than the original phone, but still. And that's more or less the interface. So now let's go to the demonstration part. Now this, if you can switch the screen to my laptop here. So I have the USRP device here with me, and instead of starting this live CD, this take 3 to 4 minutes, I'm launching it in a virtual machine in VMware. So the virtual machine is started. That's how it looks like when you start the live CD. And now I'm going to connect the transmitter. It's working. Here. Plug the USB connector. This should show at the bottom here. So yes, the USB is there. So I said one-click transmitter. That's not quite true. I have to make a double-click here. So even 3 clicks. So it should be running. So now I have a commercial receiver that was made for the German market 2 years ago. Hopefully, so it looks like well, it should be working. Let me start this small application here so that I can show you the receiver. Let's go to the camera here. Okay, now it's hopefully tuning. That's how it looks, looking for the signal, and we got it. So that's an application that we made actually to show a possibility of using user-generated content and automatically create programming, just rebroadcasting the top YouTube clips, and we inserted our own overlay text. I have another device here, which is so this was a cell phone, a GSM phone, as well as a broadcast receiver. Here, this one went to sleep. Similar thing. So that's a DAB receiver, very very nice interface. It's playing the music with an application that does slideshow. So images are coming and along the music here. We just put any pictures. That's an open source movie, if you know that, made with the open source Blender 3D rendering program. You probably don't hear the sound, but the music is playing. And finally, our own device here with the most recent operating system, update of the operating system. What did I do? I launched the device. I have to feed the power to the USB port. So that will take a second. I should have powered the device now. So the internal device, the USB key that's inside. Now I start the OpenMoCast application that we wrote for it. Takes some time. That's how it looks like. Not very nice application, but practical. So now I'm selecting tuning to the appropriate frequency. Now we're in L-band on channel 5 in Canada. And then I'm saying tune. And I have to refresh the screen manually. And then we see the different services appear. And I will go and select an audio subchannel from the multiplex and ask to play. To play, we have it here. Where's my microphone? Yeah. So you can hear it. Yes, you can applaud if you wish. Thank you. Yeah, I'm happy that it works here. So, where are we? 1 minute left. I had another demo eventually. So what we can do also, I won't do it because it's too long, but I have the USB key actually, the USB key that was put in the phone. So I can plug it in another virtual machine and broadcast from the machine and receive on the same device. So I think it's a cool demonstration. So transmitting stuff to yourself. So who said broadcasting was not a personal media? That's about it. So if we can go to the last slide. Next slide. I have the control here. Yeah. Oh, the text shrinked a little bit. So next, what do we want to do with that? Well, I'm not quite sure. and we're coming back to the political stuff. What about the networks? Who's going to put the networks out there, the broadcast networks, and can we use it for other things? But the logical things that we could imagine is doing the standard that will come for mobile television here in the US, the ATSC standard. I officially announced that we released the OpenMoCast, the software for the phone. We released that as a GPL source code. And we hope that that broadcast chipset manufacturer will be happy with our software and that they will come and try to put their technology into the receivers. Thank you very much.